intentionally. Really, my issue with Justin Bieber is that he's such a jerk. He thinks it's appropriate to race his Ferraris down the street in front of his house and like 2 in the morning and like make all that crazy noise. Like he has neighbors. Well, he acts like him. I don't. We really make a big push for everyone to bring this back here. Just grab whatever. I made a numbering system, but it should. All right. Well. Weak sauce. Okay, you got your sucker. All right, so I'll still keep that offer rolling. If you and a friend play the Win-A-Row game, you are welcome to bring me your work. Apparently some people did not hear me say bring me your work yesterday. But if you show me your work of addition of positive and negatives for Win-A-Row, I will give you a piece of candy. Other general announcements. I moved the turn-in bin and all of that stuff to over here. So it's more to the side of the classroom. Because if like in the middle of class you're trying to turn in homework, it's awkward to turn it in over there, so I just decided to move it to over here. As well as the whole puncher, stapler, tape, all that stuff should stay over there. And you guys already know that graph paper and all that stuff moved. Any other random / general questions that we need to cover before we dive into today's lesson?
What is life?
What did you say? Learn life?
What is
life? So if your groups, actually I'll go ahead and drop a couple of these at your table. If your groups want to keep a couple of these, I'm trying to get some little bins that we could keep at your table full of these different resources, but I want to keep some of these up here. We will be drawing. Hey, I'm fighting with a lot of people to talk, and the longer I have to wait, the less time we potentially have for homework. So, we are going to be drawing rectangles today, so whether you use the rectangle that's on there or just use the edges of it as a straight edge, my advice, especially if your ruler breaks, try to keep a ruler in your math binder, because just being able to quickly draw straight lines is really advantageous to being able to work better. Like, not necessarily easier, but just better. Google. All right. So, did not mean to do that. Would anybody like to read for us? All right, so let's make sure we all headed our paper. So if you haven't done that, please do so now. We're on 225, and we're multiplying portions. Apparently my Smart Ink has decided to take the morning off. So Sky, you want to go ahead and read that first paragraph for us there?
Yeah, but what's that?
Cecil. Okay, thanks. It's like, so they tried to name him like you would hear, like what am I thinking? A circus, like a circus performer's like stage name or something. So Cecil was a name you might hear like the circus.
You have now seen Cecil proceeded in picture-sized modes and can be represented with addition or multiplication. But what if you need to calculate part of a whole? For example, if 200 people enter the competition and 1/4 of them are chosen for the final round, how do you calculate how many were chosen? Sometimes you may even need to calculate a part of a whole. For example, if Cameron sprinted 2/3 of the 1/4 mile track, how would you calculate how far Cameron sprinted? Today you will use different models to answer these kinds of questions.
Thank you very much. All right, so this is exactly what you end up dealing with out in the real world. So my wife and I enjoy cooking and trying new recipes and things like that. This is the broken one. Who has the other one? Can I trade you, please? Can I? Hey, dude, I need one that lets me sit up higher. I'm sorry. This freaks me out. Because it drops down out from under me.
It's not going to be broken when I sit on it. Ready?
That's scary. Like I went to Cedar Point. Is it Cedar Point? Yeah.
Oh, the drop.
Yeah.
Power tower.
Yeah, I
Alright.
went on that and I cried.
So in the real world, not everything comes out to whole numbers. Not everything comes out to nice little, like, 5, 10, 50, like easy to count things. So a lot of times we have partials. So if you ran 2/3 of a quarter-mile track, that seems like it's going to be complicated to solve. But here's the secret. And I would like you to put this on your notes, like near the top. Of, like the word of, when we talk math, means multiply. So what 2/3 of a quarter mile actually means is take the fraction 2/3 and multiply it by 1/4. And this is what I've been like leading you guys up to, of saying multiplication of fractions is easier. Because if we were trying to add those fractions, what would we need? Common denominators. But with multiplication, we can just do it. So multiplication, this of turns into 2/3 times 1/4. Please write that out. And then I'm going to ask that you put arrows. I'm going to get my fancy pen back here. Arrow across the top, arrow across the bottom, equal sign from the top, equal sign from the bottom, and a big equals in the middle.
Oh, I already broke my rule.
You broke your rule or ruler?
My rule. I was trying to make my paper rainbow like on every line that I did, and I just
So
made
use
it
your
one
colors
line.
to activate your brain. I know you like switching colors, but you see how I use my colors to kind of like code certain things? If you're using multiple colors, would it be helpful if because this idea is still like processing, when I make those bins and stuff, would you guys like colored pencils or pens or something here? Okay, would you like use them and make sure they get put back?
Yeah, will
you
you
put
pens in there, like colored pens?
I'd have to go buy them, but yeah,
Profile
probably within a couple weeks I can get it. So, hold up. Let's look at how easy this is. What's 2 times 1?
2.
What's 3 times 4?
12.
That's how far they ran. 2/12. That's it. Now we could reduce that, right? Which we've been saying we don't have to. But what could 2 and 12 both be divided by? Yeah. Okay. So what can it be divided by? 2, which becomes 1/6. So we might want to show the division by 2, at least on the top or bottom. Joe.
But didn't you say that we should use? Didn't you say that we should start using parentheses instead of the dot?
Okay, yes. 100% yes, but when we work with fractions, that's going to make a lot in my problem. Like if I put my fraction in, I've got 2 numbers, a fraction line, and parentheses around it, that gets a little busy. So while that would do the same thing, I like drawing the arrows across, so I normally do just use the dot when working with fractions. And here's the big thing. Why did I say the dot gets dangerous?
Because it could look. Because there's no really reason that it could look like a decimal.
Yeah. There's no way that that would be a decimal, right? We would not write a number like that with a fraction, then the decimal point, and then another fraction. So there's no confusion about that being multiplication. Does that make sense?
Yeah.
Why the dot is like safe to use here.
Yeah.
Any questions right here? Well, thank you very much. It is actually really good. I'll take that compliment. Yeah, 80.
So one thing, when you do 2, okay, sorry, means multiply.
Of means multiply. So if you have 2 sets of 5 pencils, how many pencils do you have?
10.
10, because you have 2 times 5.
Also, you want to share?
This is 2-85.
Okay, moving on. Check out 85. Please go ahead and number that on your paper. So we are not yet using fractions, but this is like what you saw in your homework last night. We were talking about the distributive properties. So 2 options here. When you write this work down, especially part 2, you could distribute the multiplication, or you could solve inside the parentheses first and then do the multiplication. Excuse me, I'm going to give you guys, and you don't really need to read. This is just setting up the situation that this is part 1 of his act, and that's part 2. Part 2 gets more complicated. So if you have your 85 on your paper, please then write out that expression. I'm going to switch my screens real quick. Once you get done with part 1, make sure your group agrees. Check your answers with each other. If you disagree, talk out how you got your answer. And then move on to part 2. Okay, make sure you write the original down first.
Just 85.
285. Write the original first, please. I'll give you at least 3 minutes, probably. I always say, don't have your paper on my doors at least. And I record all my classes that will written up board. You can play in front of my class anytime because they're all on YouTube. So soon as I'm done with the class, it's just like upload oriented and Addison and then the natural medicine part of the class. Is there any distribution needed in part 1? No. Notice how we're using those parentheses for the multiplication?
How do you do that?
It's just 2 different screens. I can show you sometime, like during AO if you want. You could do it at home. It's real easy. But laptops can't really do it. You could like plug your laptop into your TV. Talk about it. I think most of you probably have an answer for part 1. Make sure you guys all agree. Yeah.
If I do my problems like this, where I this is how like it has my brain, so
Yeah.
I can do it that way.
If it makes sense to you, yeah, totally. See, in my brain, I would have merged the positives first, but I like what you did because the 5s work together really well. So I think that makes perfect sense. You got to be able to explain it though. Can you talk it out? Sweet. Once we multiply. So when you do the 2 times 3, then multiply, you get that. What's 3 times 3? So then it's 6 plus 9 plus the negative 5 plus the 4. Yeah, so you might need to erase a little bit of that and choose. Yeah, go. Yeah, write it, then explain it. Or you can do it at the same time if you want. Some kids just can't talk and read. So Sky is going to show up part 1. If you are still working on part 1, just keep working.
Can I show up part 2?
Do you have your work written down? Because I'm going to check it before you go up to do it, yeah? Because it's a big act. You paid to get in the circus. You don't want to be bored. No, Cecil's like, well, you paid to get into the circus. You can get your part 2. All right, so Sky's going to talk this out for us. And then we're going to keep working on part 2. So, Sky.
So since I know that parentheses means to multiply the numbers, I knew that 3 times 2 is 6, and 3 times 3 is 9. So I did the parentheses, like the numbers that had parentheses first. And I did that, and then I just brought those 2 down. And then I added those 2, which I knew was 4. And then I brought those down, and then added the 4s, and then brought the 6 down, and then...
Nice. Now this is potentially different than yours because I think there's at least 7 different ways to solve this problem. So remember, a lot of right ways to get to Florida, but did you get the same answer is what you want to check. It is 14. In the end, his act takes him 14. So work on part 2. If you're not done with that yet, I got to write it up here, then I'll come around. Actually, Mr. Smith, do you have a question or are you trying to do the answer? Yeah, let me write it up here first.
That was right.
Mr. Smith, do you want to check his work? Make sure we're good? Thank you.
Oh.
I'm going to run out of space. This is so long.
I know.
I have to write smaller.
Can I write it for you?
Brennan already asked, actually, so we're going to let him as long as he's
Not
working.
do the problem.
She was going to write it.
Oh, sorry, I'm halfway in. Maybe next time.
Oh, I got it.
Brendan
Mr.
should
Smith just checked my work.
Brendan should
He just said that Brent put this.
Yeah.
But I was supposed to.
Oh,
Aiden, I'll get you on the next one, Junior.
I was supposed to.
All right. Your work all good? Here, because this is so big, I'm going to give you a slightly thinner marker. Anybody else have questions? Want some help on? I'm not even sure about the answer. All right. I love how our brains are different.
You got 10?
I love our brains. So, check it.
18.
Check it. So, I'm going to explain this because I'm on the outside looking in. Actually, Brent, you want to go ahead and give it a start, and then I'll help with you. So, give your attention up here, please.
5 plus 3 equals 8, and you can't add 4 because you have to times 4 times what's in the box before you can add it with the 5 plus 3, which is 8. So 1 plus negative 1 equals 0, so 4 times 0 equals 0, so 8 plus 0 equals
Keep talking, you're good.
and then you have to add negative 3, which 8 plus negative 3 equals 5, and then you have to add 5 plus negative 5, which equals 0, and then you have again do the multiplication before you can add the 3. So 5 plus negative 2 equals 3, so 3 times 3 equals 9, plus 1 equals 10.
So, Brendan did everything here a little spread out, and like, I work purely vertically, right, when I do it, but if this is how Brendan's brain sees the problem and can break it up and bring it all back together, this is fantastic. The answer is 10. The answer is 10. So, thank you very much. So, if you have an error, you want to check it. Now, hold up. Hold on, back up here. Back up here. We'll go back to that later, but we have a lot to get through here. So, here's what we then get asked first. So, these were the two different parts of his act, right? Part 1, he went 14 feet. Part 2, he went 10 feet. And then he ended at the end, right? So, I'm probably going to zoom in a bit more up on the TV. If we call the tightrope one whole act, we call the tightrope one whole act. So, we have from start to end the entire tightrope. What is the entire length of the tightrope? If we had part 1 was 14, part 2 was 10, Ethan? 24.
28.
So the tightrope was 24 feet long. Go ahead and put that on your paper. Part 1 was 14 feet. Part 2 was 10 feet. And if we want to talk about portion of the tightrope traveled, what should I put these numbers over? If we want to talk about portion of tightrope traveled, what's my whole here? Do you know what's the entire thing? What was that, Isaac? 24. The whole tightrope is 24. So if we want to make these portions, it would be 14 24ths traveled in the first part and 10 24ths traveled in the second part. And we could reduce these fractions, but we don't need to right now. We're just going to leave them there because we know you traveled 14 feet out of the total 24 and 10 feet out of the total 24. Now, we're going to extend this. If Cecil has his allergies kicking out, which Mrs. Pettigrew was just this morning talking about her allergies, and he has made it 2/3 of the tightrope, like of the whole thing, both parts put together, then he sneezes and falls. Now it's okay, he's attached, right? Like the dude we saw on the slack line, he's attached. So I want you guys at your group to figure out, now you might want to draw a new picture here. Now what we're talking about is 2/3. Right, so I try to approximate how far had he traveled when he sneezed and fell. If he had traveled 2/3 of the tightrope, how far was that? How many feet? So now part 1 and part 2 don't matter. We're just looking at the entire tightrope. If he traveled 2/3 of, well, what comes after the of? This is 2/3 of 24.
Good job, Aiden.
How do I make 24 into a fraction, Natalie?
Well, you multiply the top and bottom by 8.
I don't have a bottom. What I need, what should my denominator be over here? 1. Any number can be put over 1 and it doesn't change it. Of tells me to multiply, so I could either actually just like leave the word if I wanted to, or I can put in the dot. Now, we could do cross-reducing here, but we'll hit more on cross-reducing later. If I need to do 2 times 24, break it apart. What's 2 times 20? 40. What's 2 times 4? 8. So we get 48 thirds. Then if we want to reduce it, again, make your life easy. I'm going to think about 48 as 30 and 18, right? 48 is 30 and 18. What's 30 divided by 3? 10. What's 18 divided by 3? 6. He went 16. Are you going to reduce?
How did you get 40? I'm sorry.
So the 2 times 24, we broke it up, and 2 times 20 was 40, 2 times 4 is 8. Or if you just know you can double 24 and get 48, that's fine. If you just know how to get there, that's all good. Did you get the same answer? Sweet. I gotta keep moving on, so we can't take a lot of different answers on this one. I'm gonna put that up on the TV, so I'm flipping screens, and then we'll look at the next problem. Ava, what's up?
She said you're going too fast, but she's scared to tell you.
Okay, what do I need to review? What do I need to review?
Welcome, Ava. But you're going so fast, like. Okay, we're done with that problem. Like,
That was only one problem, and we're half hour into class.
Oh, God.
I know there were multiple parts. I get it, and we are moving kind of quick, but is there a part we need to go back and review? Or is it just we're moving at like a fast pace? But Ava, if you have the question, I bet so does a classmate.
oh,
16 to 24.
I do not get part 2. How did Brendan do that?
Part 2, like the 10/24. Oh, okay. So hold up. That's a really good question. So here's Brendan's work was what happened in his brain, right? That's how his brain made sense of it. My brain would have to take this and directly below the numbers in parentheses, I would have to simplify those first to get it to work for my brain. So the first thing I would do, I mean, I could add those, I could go ahead and do that, but I can't do anything with the 4 until I do this. What's 1 plus negative? 0. Then I can drop down my -3, or I could combine it with my other -5. What's -3 plus -5? -8. Now, what I could recognize right here, and like I said, we all have, I don't need 2 pluses there. We all have different brains. We all have different ways to do this. pulled up. If this was me solving this problem, I have an alarm that goes off in my head. What happens with 8 and negative 8? They get 0.
Like one.
So, are you good to hear? Are you good to hear?
Sure.
Yes?
No, it's
I know. I'm going to write the rest of it out and then make her give me a real answer. What happens when we have 5 and negative 2 meet up and fight? Who wins, the positive or the negative? Positive by how much? 3. So that's actually 3 times 3.
equals 9 plus 1.
Now, check. Hold on. Hey, I have a lot of side conversations, and if you're talking right now because you understand the problem, you're being extremely rude. I'm trying to help out one of your classmates who has taken the risk to ask for help, and if you understand it, you're just saying like, well, you don't matter, I got it, so I'm going to sit over here and talk. Coolish. Move on to the next problem if you want to do something. So, anything times 0 is 0. Right? No matter how many zeros I have, I've got 0. So then, really what I have is this, which we just said was 9, plus 1. The problem really just comes down to this, 9 plus 1.
Yeah, but why aren't we doing everything else?
We did. So, this typing, I wish this wasn't here and I could show, and we should meet up later and talk about this. Addition, as we've talked about, can be reordered. I can do it in any order I want. So, if I were to rewrite this, I move my negative 8 over with the positive 8, and I have 8 plus negative 8. Those make 0. I have 4 times 0. That makes 0. Then way over here, because I already did all that, right? That's how I got my negative 8. I have this, which is really 3 times 3, which is 9, plus 1. Now, I hate that I just worked vertically for like up, but I would have done that work, below that.
Wait, okay. So this makes more sense now. But like, okay, so you're saying that we do not need to finish the problem.
Well, we did. We just get 10.
Okay.
Because all of this other stuff made 0.
Okay.
So does that make sense? Not sure, yes or no?
No.
Okay, what part of it?
Okay, wait. Can I go up there and show you what I'm talking about?
Can we meet up later, actually?
Yeah.
Because and actually, you might, after you sit on this for a few minutes and let your brain move on, you might have that aha moment. You're probably thinking too hard. Some of the greatest, like, innovators or creative, anybody, like, sometimes you're just trying too hard and you need to walk away from it for a minute. So, guys, if you get to that point on your homework where, like, you feel like it should make sense, but it doesn't, or you're struggling and you just, like, can't get it figured out, like, walk away from it. Do something else, put your brain on something else, then come back to it later. On your paper, please draw a rectangle. You can either use the template, or you can just use the fact that you're using graph paper.
Found it.
Scott? What? Big enough to cut in half and then do some math. So it doesn't have to be real big, but big enough to visualize half. So like I said when we first started working on these things, addition, like for some reason, adding positive and negative numbers, and really fractions or whatever, that's harder for our brains to figure out. All right, the garden, I forget what they say the name is. Oh, I need that pen. Layla, whoever it is, I can't. It's dark. All right, Garden Road Middle School is planning a field trip. Hopefully they filled out the right forms. So they're going to go to a conference about mathematics. Half of the students signed up to go on the field trip, but 3/4 of those brought back their permission slips to actually attend. What fraction can't go because they didn't bring back a fourth of the people that wanted to go, right? So here's our school, right? This rectangle represents our entire school. And you can actually put multiple rectangles on your paper if you want, or you can work with the same rectangle. This, we could show half the school wanting to go by cutting it in half and shading or highlighting or whatever one half. So go ahead and do that right now with your rectangle. try to actually make it cut in half, like for real, in the middle. So then, if we want to show that 3/4 didn't bring back, or sorry, 3/4 did bring back their permission slip, what can I do to this rectangle to make it show 3/4 of... Careful. Yeah, Joey's got his hand up there.
But, like, with the half that you already made, you can just put a thing in the middle of things.
Thing in the middle of the things.
Yeah.
Cut it in half.
Verbs.
And then
So,
shape one of the
if I cut it, as Aiden said, into 4ths, and then I need to shade somehow differently. So maybe either a different color or a different direction. So I'm going to go perpendicular. Yeah. Yeah. So now, how much of our rectangle is double shaded? Ava?
3/4.
Ooh, careful.
3/8.
These are my double shaded, right? 3/8. 3/4 is single shaded. So my double shaded are these regions. They die at the end of the movie.
I'm sorry, I didn't mean to blurt that out. I'm so sorry.
It's okay. Alright, so now, hold on, so you gotta work this with your team. Well, it's not really we do cross multiplication to solve proportions. So I know what you're saying, at least I think I do. So let me come look at your work here in just a second. If the school has, in total, 120 kids, how many are actually going on the trip? So figure that out with your team. If the school has a total of 120 kids, how many are going on the trip? So what are you saying? Are you saying not a business multiplication sign. So that's the biggest enemy, is the fact that some of you guys have already seen cross multiplication. We use cross multiplying to solve a proportion. So here's this poster right up here. If I have a fraction equal to another fraction, I then cross multiply those. So I will show you how we can use cross multiplication here, because that is one of our techniques. So as I hear some people saying out loud, we could multiply 3/8 of 120. Right? We could do 3/8 times 120, and that would be fine. However, Eva is over there asking. Sorry, so this is what a lot of us are doing right now. Eva's asking me about cross multiplication though, which she's just real close to how we would do it. Cross multiplication only happens if you have a fraction equal to a fraction. Right, Nathan? What'd I say? Well, why? Is it related to what we're doing right now? Come on, man. Come on, man. If you don't want to be in here, there's no door blocking you. Isaac, if I'm talking, you shouldn't be talking about really anything. I like that it was math, but here's what's up. 3 is the portion of kids who brought in their permission slip and want to go. Right? It's my double shaded region. 8 is my total of the school. Now, you don't have to know how to do this, but if you know, like if your 6th grade teacher showed you cross multiplication, I want to make sure you understand where it comes into play. We're solving for how many kids are going. Out of how many? 120.
Oh my goodness.
So we can, just like we've done before, figure out how do I multiply to get here. Or, since Eva brought up cross multiplication, I make my unknown a variable. I'm going to say M for math nerds. right? Because they're going on that trip. So then 8m equals 360. Right? 8 times m, 3 times 120. Then we solve this by dividing by 8, and we would get m equals something. What did you guys get for m up here in this fraction?
I got 360 over 8.
360 over 8, right? That's what we just got right here for m.
I did it right?
It's the same answer regardless of which way you take it. Now, we want to solve this, right? Because I'm not going to take 368ths of kids, right? That's creepy. So, can 36 divide by 8?
Yes.
What is
16, 24.
32, right? Not 36.
Yeah, not 36.
So, you might need a calculator. Hey! I don't like fighting with us all the time. So, I have a feeling this might be better with new groups on Monday, but I'm going to start to be strategic with who can sit with who.
Can I interrupt you for a second?
Yeah, you're good.
They're setting up the vision screen thing. And
Oh,
they
yeah.
don't have a measuring tape. Do you have a...
I think this is inches and yes. You can use a calculator to help you with this. A fraction. This was like, I love that some of you still think this because your 6th grade teachers totally must have breezed over this. A fraction is division. And division is a fraction. So when you grab these calculators, they don't have the ABC fraction button that you're used to. They do have an ND button, a numerator denominator button. But when you see this fraction bar, 360 over 8, it just says 360 divide by 8. Now you have to type it in that order. So somebody with a calculator, what is 360 divided by 8? 45. So I know you'd said it before, but I wanted to. So either way that you solve it, you get 45.
You can do a fraction or a fraction or a fraction or a fraction.
You can, but it's not appropriate, really. You could do fraction times fraction times fraction.
45.
All right, questions on that? Please write on your paper another rectangle, or draw, I guess. If you're doing graph paper, I would make it 8 wide. If you're using graph paper, I would make it 8 wide. Yes. It's, you guys will all get called down. Let me check your eyes. 8th grade. This guy right here. All right, so Howie has 5/8 of his pizza left from the night before. Right? He bought a pizza and he ate 3 slices probably. Now he has 5 left. So if we try to draw this on our sheet, it's easier to make 8s vertically because it's wider than it is tall. So if I split this into 8s, luckily my graph paper helps me. You should have 7 lines to make 8s, and then shade 5 of them. Right, he ate these. These are gone. Now, he decides he's going to have it for breakfast and probably lunch. So, since he wants it to be good for 2 more meals, at breakfast, he's only going to eat half of it. How much of the pizza does he eat at breakfast? So chat with your group real quick. Draw whatever else we need to draw here to show he's going to eat half at breakfast. I'm going to give you a 30-second head start. Yeah, which I have no idea how they're just going to call down on people. Yeah, I would keep that, but they just do this for all kids here. If you already have glasses, so they'll probably just like be like, okay, you're already good. But this is really for kids who don't have glasses, that we need to identify them. Like in 8th grade, they identify that I need glasses. So this is just for kids that haven't been caught by the optometrist. Luckily, you haven't. really they're going to make sure your glasses are working correctly. Because your eyes change as you grow. Yeah, it's all good. Don't let this make you nervous. You go down, you read the chart however far you can. This is not as good as going to your so still good. You're all good. No, this is something the state does or the district that we have. It's one of those things. All right, what else do I need to draw? Let's go someone new. Yeah, Jalen, what do I need to draw? Real fast, we have 2 minutes. I guess well, that's not a very straight line. It's okay. Okay, so I'm going to stop you actually. This is not using this appropriately. So I agree with how Jalen drew a line across. You go perpendicular with the lines that are already there. Sorry, dear. This is why I like to check papers before I have people come up here. If I draw my line horizontally for half, I need to shade the entire above half or the entire below half. So we shade, if I'm doing top, I'm going to do all of that. How many parts are double shaded? 5, right? Out of how many total parts do I have now? 16. So he ate 5/16 of the pizza for breakfast. Question? It depends on what you think about slices. Maybe there were 16 slices from the beginning. Yeah. No, he had 5/8 of the pizza left. So he had these left, but then he ate them. So we kind of
report to the art room.
7th graders.
If you wear glasses, please bring your glasses down. We're doing some
Hold on.
screening
You're going to need to
today.
take your stuff.
7th graders, last name's letter A through F, to the art room, and please bring your glasses. Thank you.
I'll bet that you can see your stuff in that hallway outside that room. Hey, Casey, chill. So, you need to pack up your stuff. We're changing classes right now. That's it for today. So, pack up your stuff. Take it with you. Your last name, A through S. Go to the art room. Art room.